So this is a National 4, National 5 chemistry lesson looking at bonding, and in particular this lesson is going to be focused on electron cloud diagrams, and this lesson is very much related to the previous lesson on shapes of covalent molecules. So the aim is to identify what shapes will form using electron cloud diagrams. So our success criteria: be able to state the 4 shapes that covalent bonds form, determine the shapes of molecules given the elements that they're made out of, and explain how these shapes are formed using electron cloud diagrams. So this is a task you can do to see if you can remember from last time, but can you draw the shape of hydrogen chloride, water, ammonia, and carbon tetrachloride, CCl4? So can you have a go at drawing those? Or if you're not sure, can you remember the shape at least of those molecules? So if you needed to pause the video in order to have a go at drawing them, that's okay. But what we can say is that hydrogen chloride is a linear molecule with a single bond between hydrogen and chlorine. Water is angular, so it's sort of a bent-shaped molecule. There are 2 single bonds, a single bond between one hydrogen and the oxygen, and a single bond from the other hydrogen to the oxygen. Ammonia forms a trigonal pyramid. So we have hydrogen at the top of the pyramid, and there are 3 single bonds coming from hydrogen to each of the 3 hydrogen atoms. Carbon tetrachloride would have a similar structure to methane. It's got 4 bonds around a carbon, and so it is tetrahedral in shape. So you would have 1 carbon at the center with a single bond to chlorine pointing up, and then 3 bonds to chlorine pointing down. Now what we're going to look at now is another way of representing atoms. So atoms, previously what we've looked at is every atom looking like a circle. But this is a different way, and it can sometimes help people to realize where covalent bonds are going to form. So the first thing that we need to do is look at how we can represent atoms using a cloud diagram. Now, if the element or the atom is in the first row, so hydrogen or helium, we draw a circle. And we then draw in the number of electrons inside the circle. And what we do is if it's hydrogen, there's 1. If it's helium, there's 2. Now we know that elements from the first row want to have 2 electrons in their outer shell. So hydrogen only has 1, and there is space for another electron, which means 1 bond can form. Helium, on the other side, has no unpaired electrons. It has 2 electrons, it needs 2 electrons, so no bonds can form. When it comes to elements from the second or the third row, what we draw is we write the symbol for the element in the center, and then we draw 4 sort of loops coming out at the top, bottom, left, and right. And what we do is we start in 1 loop and we put 1 electron. Then we move to the next one, put an electron, the next one, 1 electron, and so on. So you go round clockwise, putting in 1 electron at a time until you get to the number of electrons that atom has. So for example, nitrogen. Nitrogen has 5 electrons in its outer shell. So we start at the lobe or the loop at the top, we put 1 electron, then we move clockwise, we put 1 electron, clockwise, so we're now at the bottom, put 1 electron, and then we move clockwise again, we put 1 electron, we put 4 in. Now we're back at the top and we put in our 5th electron. And then we look at our diagram. And we know that nitrogen wants to form a structure that has 8 electrons in its outer shell. Each one of these lobes can put 2 electrons in total in it. We have one that's completely filled, it's got 2 electrons. The other ones only have 1 electron each. They need to pair up with something, and each one of those lobes will form a bond. It has 3 unpaired electrons, and so it can make 3 bonds. Oxygen, if we do the same thing, we start at the top and work our way in a circle, putting 1 electron at a time. Well, oxygen has 6 electrons, so if we go around putting 1 electron at a time clockwise, we end up with 2 filled lobes and 2 lobes where there are unpaired electrons. And that means that oxygen can make 2 bonds. So using these electron cloud diagrams, anywhere there is an electron on its own inside one of the lobes, that atom can form a bond. And whenever atoms bond, what you do is you overlap the 2 lobes that each have 1 electron inside it. It might sound a bit difficult, but when you start to see the diagrams, it becomes a bit more clear. So here we have hydrogen chloride. So chlorine has 7 electrons in its outer shell, and if we start at the top and work our way around putting in 1 electron at a time, we end up with 3 lobes, each with 2 electrons in it, and 1 lobe on the left-hand side with only 1 electron, an unpaired electron. Hydrogen, because it's in the first row, we draw a circle. It only has 1 electron, so we draw that in. It wants to be paired up. And so we've got 1 lobe on chlorine that wants to pair up, and we've got 1 hydrogen that wants to pair up. So we overlap those 2 diagrams, and we can see now that the hydrogen and the chlorine have formed a bond, how they have overlapped. The hydrogen now has 2 electrons, the chlorine has 8 electrons. There's 1 overlap, so that means 1 covalent bond. And the chemical formula would be HCl. Now, you can do something similar for chlorine and fluorine. So if you want to have a go, pause the video. Remember, use your data booklet, page 6, so that you can see the electron arrangements. And remember, you're only using the outermost electrons for these diagrams. So I'm hoping that you've unpaused the video and you've had a go at least one of these, if not both of them. Well, chlorine, each chlorine has 7 electrons, and that means that each one can form 1 bond. There'd be 1 lobe that's not paired, and so what you do is you overlap those 2 lobes, 1 from each chlorine, to create a molecule that looks like that. And fluorine does exactly the same thing. It has 7 electrons in its outer shell, leaves 1 lobe from each fluorine with an unpaired electron, overlap those 2 lobes, and you end up with 1 bond forming. For nitrogen, what we need to do is draw the electron clouds for it and have a go. Now, nitrogen is one of the more complicated ones because when you put in 5 electrons in the diagram, it means that there are 3 lobes that have 1 electron in each. And so in order to get 2 nitrogens to bond, we need 3 lobes from each nitrogen to overlap. And so if we look at the diagram like this, we can see why there are 3 bonds, or what we call a triple bond between the 2 nitrogen atoms. So now we have carbon fluoride. Now carbon has 4 electrons, and so if you go round the diagram for carbon, it means every single one of its lobes has 1 electron. And for fluorine, fluorine has 7 electrons, which means only one of its lobes has a single electron. And when you put them all together, overlapping the lobes that only have 1 electron in them, you end up with quite a big diagram like this. And you can see that the carbon forms 4 bonds and it's bonded to 4 different fluorine atoms. So this is one for you to try. So this is phosphorus chloride. So I'd like you to have a go, pause the video and have a go at drawing this for yourself. You will probably want to use the data booklet. If you don't have access to the data booklet, I'll let you know that phosphorus has 5 electrons in its outer shell and chlorine has 7 electrons in its outer shell. So if you have paused and had a go at that, well then this is what it should look like. So phosphorus can form 3 bonds because it's got 3 orbitals with 1 electron in them, and each chlorine only has 1 lobe that's got 1 electron in it. So you need 3 chlorines to bond to the phosphorus in order to get it to have 8 electrons. So it's PCl3 and it's 3 single bonds to phosphorus. And the shape of that molecule, because it's got 3 bonds, would be trigonal pyramidal. So this one is ammonia. You should know the shape of ammonia, but have a go at drawing this using an electron cloud diagram this time. In case you weren't sure, nitrogen has 5 electrons in its outer shell and hydrogen has 1 electron in its outer shell. And so it should look like this, where 3 bonds are formed, because nitrogen has 5 electrons, that gives it 3 lobes with only 1 electron in it. And the hydrogens, remember the hydrogens are circles because that's in the first row. And when you put it together, it looks like this. And the shape of that molecule would be trigonal pyramidal. Sulfur iodide. This is probably one of the bigger ones you'd have to do, but sulfur iodide. Sulfur has 6 electrons in its outer shell and iodine has 7 electrons in its outer shell. So have a go at drawing that one. If you need some extra time, pause the video. And so if this is you coming back after having paused it, it should look like this. So sulfur has 6 electrons in its outer shell. And if you go around each one in turn, filling it with 1 electron at a time, it means that there are 2 lobes that only have 1 electron in them. For iodine, it has 7 electrons in its outer shell, which means only 1 lobe gets left without an electron. When you overlap the lobes, you end up with something like this, where there are 2 covalent bonds formed and the sulfur is in the middle. And the shape of that molecule is angular, just like water. So now we have hydrogen sulfide. So hydrogen has 1 electron in its outer shell, and sulfur, like the last question, has 6 electrons in its outer shell. Again, if you need to pause the video to give yourself extra time, do so now. If not, then hopefully you've got your diagram done, and it should look like this. So sulfur has 6 electrons in its outer shell, which leaves it with 2 lobes with 1 electron each. Hydrogen is in the first row, so it's shaped like a circle and has 1 electron in it. And so when you overlap them, you overlap like this. And this also has an angular shape, just like water. Carbon dioxide. Okay, carbon dioxide. Carbon has 4 electrons in its outer shell. Oxygen has 6 electrons in its outer shell. So hopefully you've had a chance to draw that, or you've paused the video now to make sure you've had time. But the shape of that one is like this. So if we look at the center for carbon, carbon has 4 electrons. So that means every single one of its lobes has an unpaired electron and will need to form a bond. Each oxygen has 6 electrons, and that means only 2 of its lobes are able to bond. And so each oxygen comes in on either side of the carbon molecule, of the carbon atom, to form a molecule like this. And it is linear. So you could draw a straight line through the oxygen, the carbon, and the other oxygen. That's a linear molecule. So hopefully you feel that you are able to draw the 4 shapes of covalent bonds. You remember the shapes of the molecules, and you can determine the shapes given the elements, and you can explain these in terms of using electron cloud diagrams. Electron cloud diagrams are a bit confusing and they may take time, so you might want to watch this video another time just to make sure that you're familiar with this. So here's some recap. Draw an electron cloud diagram to represent hydrogen sulfide. As before, if you need to pause the video to give yourself extra time, just do so. But hydrogen sulfide looks like this. Sulfur has 6 electrons. That means 2 of its lobes are not completed and only have 1 electron. And hydrogen is a circle with 1 electron. You overlap the hydrogen with the lobe that only has 1 electron, and you end up with hydrogen sulfide like that. So here is a diagram representing hydrogen chloride. It's asking for the name of that bonding. Well, hydrogen is a non-metal and chlorine is a non-metal, so that is covalent. And we're asked to draw a diagram to represent phosphine, and it's showing all of the outer electrons. So that is our diagram. So there should be a P in the middle. And you've got 4 lobes. 1 lobe has got 2 electrons in it for phosphorus. 3 have only 1, so you need 3 hydrogens to overlap. And the shape of that molecule would be trigonal pyramidal. So that has been a review of electron diagrams in order to understand the shapes of molecules. And I will catch you next time.